Hey there, this is a video on arc length and area of a sector of a circle. Right away, what I want to do is I want to make sure you have a good definition for what arc length is because it can be confusing with arc measure. Arc length is actually how long the arc is in inches, feet, miles, centimeters, something like that. Arc measure is in degrees, and it's a portion of the full 360 degrees that a circle is. So make sure you kind of separate that right away. Arc measure is in degrees, arc length is distance, and that's measured in inches, feet, miles, etc. Okay, so the way that I want you to think about arc length is it's a fraction of a circle's circumference. It's a fraction of a circle's circumference. Remember, I talked to you about an arc is a piece of a circle. So you're going to figure out what portion of that circle that arc is, and that's the portion of the circumference of that circle that's going to tell you the length of that arc. So it's going to be a fraction of the circle's circumference. All right, so here we go. I'm going to do an example with you, and you can see this worked out over there to the left, but I'm just going to walk through it step by step for you, and you can kind of see how we're going to do it. Okay, they tell us that the radius xy is 10. So we'll go ahead and label our picture there. And they told us that our central angle here is 40 degrees. Now remember, central angle and arc measure is the exact same thing. So if they want us to figure out the arc measure for this thing right here, we are going to use the radius of 10 and an arc measure of 40. All right, here we go. Let's figure this out. So for our example one, here we go. So arc length is going to be the fraction of the circumference. So the fraction is the arc measure. So in this case, the arc measure is 40 degrees out of the total 360. So there's the fraction piece that we're talking about, 40 out of 360. And then we're going to multiply that by the circumference, the 2 pi r. So 2 times par times the radius of 10. So the definition is the formula, fraction of circumference. All right, so let's simplify. 40 out of 360 is 1/9. 2 times 10 is 20 times pi is 20 pi. So now when I multiply fractions, I'll just do top times the top, bottom times the bottom, and I get 20 pi over 9. And I'm just going to leave it like that for exact answer purposes. So the length of the arc xz would be 20 pi over 9 units, whatever the units that they give you. And you could do that exact same thing in that second example there, where you're going to need to figure out what the length of arc RT is, and you'll just do some subtracting. 360 minus 246, and that'll give you 114. So we could put that over here for our arc measure, 114 degrees, and then I'll use 12 as my radius. So for my example number 2, if I do arc length, we're going to do this time, the fraction is 114 out of 360 times 2 pi times 12, because that's our new radius. All right, and then you just simplify and multiply. So 114 out of 360, 57 out of 180. So it doesn't simplify as nice as we like, 24 pi. And then you could just simplify from there as you continue to work this out. So 50, so top times the top, bottom times the bottom, and you could just simplify. So I'll do that really quick for you. Sorry, 57 times 24 is 1,368 over pi. And then you got 180 on the bottom. Probably could have simplified that from the start. Actually, let's go back and do that. I apologize for the haste here. Let's try that one more time. 24 and 180, they have a common factor of 12. So we can divide both by 12, and you get 15 here and 2 here. So then 114 pi over 15 is your simplified exact answer units for your length of this. All right, so that's how you're going to do arc length. Let's move to area of a sector. Okay, so very similar, the area of a sector, and you can even look ahead at that formula and see that it's very similar, except for one tiny difference right there. All right, so real quick, let's get some basics. The area of a sector is like the area of a pizza slice. It's the portion of a circle's area that is being used. So a sector is like a section of the area, the interior space, not space, but interior area of that circle. So I like to think about it like a pizza slice, and I like to think about area of a sector as a fraction of the circle's area, a fraction of the circle's area. So the fraction is the same as arc length. So it's arc measure over 360. So that's where you're going to get the fraction from. So part out of total, and then we multiply it by the area. Now, area of a circle is different than circumference. It's pi times the radius squared. So let's do these examples together here. All right, we see that our radius is 4, and that this arc here that we're interested in is 30 degrees. So when we want to do area of the sector, we're going to do 30 out of 360, part out of total, that's the fraction piece, times, now be careful, we're doing area this time, pi times the radius squared. All right, so that's going to give me 30 out of 360, and when I simplify that, I get 1 out of 12, and then 4 squared is 16, so this is 16 pi. Now, 16 and 12 have a common factor of 4, so I could divide both of these by 4 and get 3 up down there and a 4 up here, and this is going to give me 4 pi over 3 units squared for my area of that sector in example 1. So again, units are squared because we're talking about area. Area of a sector is the fraction of a circle's area. We could do the second example. Got to do a little bit of subtraction. 360 minus the 200, that's already there, and you get 160. So my area of my sector is going to be fraction of 160 out of 360 times the area, pi times 7, my radius, squared. All right. 160 out of 360 is going to reduce to 80 over 180, 40 over 90, 4 over 9. And then 7 squared is 49. So 49 pi over 9. 49 and 9 don't have any common factors, so we're just going to multiply top times the top, bottom times the bottom. 4 times 49 is 196 pi over 9. Just a real quick check to see if those can simplify. See if they have a common factor. And I don't believe they do. So we're going to leave that as 196 pi over 9 units squared. And that's our area of that second sector. Okay, I hope that was helpful. Feel free to pause and rewind and check out any of the definitions that I laid out for you. If you don't have these notes, you definitely want to write everything down. If you do have them, they do have some decent descriptions ahead as far as what arc length and area of a sector are in their formulas. So feel free to rewind, pause your screen, check it out. I hope this was helpful. Good luck, and thank you for listening.